So with this histogram creator, what we're going to look at is what happens to the distribution of data when we change the widths. Now this one is a histogram, but it's a frequency histogram, not a frequency density one. Okay, so we are just going to look at the effect of having different numbers of groups. So the smaller the group, the thinner and more bars there are. I just want you to just quickly have a look at what it looks like. So on page 201, you'll see a stem and leaf diagram there, which in itself sort of looks like a box plot, not a box, a histogram anyway, right? What do you notice about the 4, 5, and 6 though?
They're farther apart.
Okay, and they haven't carried on writing across. So actually the shape of it there looks, it's not as it should be as a histogram or a bar chart. Now all I want you to do is, just to start with, I want you to put that data from the stem and leaf diagram into this table. All you're going to do. Now it's going to be a bit labour intensive, so all these numbers here, you're basically going to get rid of. All right, so delete that one and put the first number in. So you just put an 8. Then you put the next number in is another 8, is a 9, right? Then there's no 1, so we put the next number is 21, and then we've got 22, 22, and so on, yeah? And you'll notice that there's a limit of 17 here. Don't worry about that. Just keep going down the list until you've put all the numbers in the stem and leaf diagram in. All right? So when you've entered your data, you'll see your screen. You zoom out, and it looks like that. But down here, look, it says on the instructions, B is the number of bins or bars in your histogram, right? You can choose anywhere between 0 or 1 bar up to 14 different bars. And what I want you to see is just have a play and just see what happens to the shapes and which one do you think is the most useful, just by making the bars. But I want you to think, why do the bars change so much? What are we doing? Well, have a research first, and then a couple of minutes we'll talk about it. So it doesn't matter if you haven't finished. Well, if you haven't finished all the data, you need some, but have a look at what happens to the shape. So to represent this data, I've got my histogram on the screen. Yours may or may not look the same. But what do you notice is we cut the number of bars down. Okay. So for instance, that's what the bar looks like with only 4 groups. All right. What is happening? For instance, even going from 4 to 5 intervals there, what do you see happens? Kieran? Well, what do you notice about the distribution? If we're talking precise, what do you notice about distribution there, actually, Greg?
With the class interval 4, the data appears to be have one mode.
Can I just check? It's not class interval of 4. It's 4 class intervals.
4 class intervals. It appears to have one mode, but
yeah.
when you have 5 class intervals, it becomes bimodal all of a sudden.
And where is that second mode? Because if you notice on 4, the data appears to be mainly at the left-hand end, right?
Mm-hmm.
This peak, I'll ignore this one. This peak is taller than that one, and this is high. So I would kind of assume a skew towards the left-hand, or sorry, right-hand skew, wouldn't it? A positive skew. But if I just go to one more, actually look what happens. More of it appears to go towards the other end. So I've almost changed the distribution completely by just having one more group. All right, and why is that? So if we go back to 4, what does that say about the data in this bar? So I've got whatever that is, so from 38 to 68, all right? Where is the majority of the data in that bar? Nearer 38 or nearer 68?
You can't tell.
Well, I can, because as soon as I make 5 bars,
Well, then you
I get another bar, which is towards the top end, right?
Well, yeah,
And less of them go down. Does that make sense?
yeah.
So the more bars. Now, but then if I keep going up, look, I get more and more detail. At what point do you think I get too much detail? So what do you notice? I mean, is it useful to know about that little gap down there?
Yes. Depends.
Go on then. Why does it depend? Why yes? Why does it depend?
It depends on if the data, what the data is for. Because if this data is for something that does not need to be incredibly precise, say like, I don't know.
Well, I would be looking at go on, Thibaut, what are you going to say?
I think it's too precise enough. We don't really need to show it because it's like the range is almost 90, and the gap is only 5, and it's only a very small portion that it's
Yeah, so that gap is a bit kind of like it's not significant enough, is what we're saying. So it says the stem and leaf diagrams are the weights measured to the nearest gram of a fish caught in a river. So is that gap significant enough to have it? Probably not. No. Are they outliers? No. So we can probably kind of also, does it matter? This drop here is that if I graph it, I'm basically saying that's a significant drop. But is it? Think about the weights of fish. It's 40. There's only a couple of kilos that it's saying there, or pounds, whatever it's in. Is it interesting to know that there's a drop there? Or is it just that I just didn't happen to catch any fish of that weight? It's insignificant, isn't it? That little drop is insignificant. But I'm now starting to get detail in there that I really don't need. So what we're looking for is, let's find a point where I get the information, which is basically, where do I get peaks that I need to know about? Now, do you think that peak is significant?
I think it is.
Think it is? Well, it's a significant amount of frequency, isn't it? From, it's 12 or whatever out of 4. But it's about how many there are. It's a difficult question for me to ask you. It's a difficult one to discuss. So basically, there's no specific correct answer. This is why statistics are used in such a way. It's you are trying to show the data that best represents whatever argument you're trying to show. Okay? What about that one? Yeah, bimodal, definitely. Does that show more information than previously?
Not really. I mean, yes, in the sense
So,
that
I look at that and I look at how much difference kind of that is to that.
Yeah, well, just to your eyes, but like seeing that big clump now, like you know that there's like a lot.
Yeah, basically, what are we looking at? We're looking at we're catching fish. What kind of information am I hoping for at the end? What kind of statement am I hoping to be able to make?
when one variable increase other.
No, not with the frequency, because we're not talking about scatter plot stuff. We've only got one variable here, isn't it, which is the weight of the fish, and then we've got frequency. So if I'm analysing the data of this, what am I analysing it for? What's my purpose?
I don't know. Maybe if I was collecting the data, I would myself, if I was one fishing, I'd try to make it seem like I caught a lot of heavy fish. I don't know.
Well, let's just say you're not trying to make it look like something. You're actually trying to do an analysis. This is data being collected for you. What am I hoping to? What kind of statement am I wanting to make?
That some of the fish in
Yeah, I mean, you're going into more detail than I maybe do, but what am I looking for? If I'm a scientist and I'm analysing weights of fish, I'm looking for what generally is the weight of the fish in that area.
Okay,
Yeah? And I'm looking for how much information do I need? So is it relevant to have this little peak at the end, or do I basically just need enough information, to show me? Now, I might kind of look at it and go, well, do I need that peak, for instance? All right. Well, I'm not actually asking you to answer this now. What I'm asking you to realise is that when you do these, when you determine your class intervals, you need to think it's not just a random selection of, well, I'll just do that. All right? Now, let me ask you this. Go on, Greg, sorry.
Would there be any situation where it would make any sense to have like 1 or 2 class intervals?
Essentially. If I haven't got much range of data, if the range is so small, then yeah, why not?
Okay.
Yeah, it depends how much detail I need. Now, let me ask you this. Is there any argument in this to suggest I should not do a frequency histogram, but change it into frequency density and change the group sizes?
No.
Here?
maybe because some of the bonds are really similar,
Yeah.
and there's also a couple bonds that are
No, I think, you're getting the right idea. Greg?
Me personally, I just can't see any reason why. Maybe I don't understand, but I don't know why you would want to do frequency density histogram over a regular frequency.
Well, again, why do I have to do frequency density at times? What's the reason for doing frequency density?
Class intervals.
Because I have to have, I've chosen to have different class intervals. Yeah?
Well, why here would you?
Okay.
Like, why would if you had the same class intervals? Why would you?
All right. So if I've got the same class intervals, why might I choose? Now, do you remember when we did the histogram frequency density on those questions? Where were the widest bars?
On the left and the right.
So at the extremes.
Yeah.
Where do I want, again, thinking about other things we've done, where do I want the most detailed information? Middle. Interquartile range, middle 50%.
Yeah.
Where do I not need so much information?
Out the far left.
Yeah? Could I not argue that here? Could I not say, actually, most of my information I'm interested about is in this middle range?
Yeah.
Healthy weight of fish. Maybe I want to break that up because I need more information about, well, that fish is slightly under. But what about all these little ones? Is there enough frequency to justify having their own little bars? Is the jump down there, is it significant that I need to know? Or could I just put those first 4 bars into one bar
Yeah.
and have one wide bar? And what about at the other end? Does this top bar need to be its own bar? Or could I just make it a 75 and above bar? Right? Yeah?
I mean, it just seems unnecessary because if you do want to look at the interquartile range, then you could just cut out the bottom and top.
Oh, yeah, but
75%.
we try not to eliminate information just because we don't want it to see it. It's there. We should acknowledge it's there. If we determine things are outliers, we might decide that's a reason to get rid of it. Just because it's the outer 25% doesn't mean we don't consider it at all. We need it there. But what I'm saying is, in this bar, it makes sense, doesn't it, to have the thinner bars, the smaller class intervals in the middle, but on the outsides, we don't. we can group them together. And that's the reason for having different class intervals, is when you want to take lots of small groups, like I've got down here on this left-hand side. I kind of want to make them just one big group, all right? But I don't want to lose the detail in the middle groups, all right? So I keep them as they are. So that's why a frequency histogram would turn into frequency density if I wanted to change some of the groups. And it generally is the outside bars that become the wider bars, just to include lots of potentially individual results that I don't care if they're individual. All right, make sense?
Yeah.
Okay. So what I've done as much talking as I need to with histograms and things. You need to have a look through that chapter now. Right? We've done a lot of talking. You need to go through it and just make sure you can do everything it talks about. All right? Within that. So have a quick flick through. So you're basically going from page 177 all the way through to 207, where it says mixed practice. If you want to go for the mixed practice to show that you know how to do it, but have a quick look, make any notes that you feel are missing in your notes, and then I think it'll be time to move on from histograms. All right? Let me know if you have any questions.